Welcome to Astronomy Daily, where we bring you the latest space and astronomy news. I'm your host, Anna, and today we have an absolutely fascinating lineup of stories from across the cosmos. We'll be covering ESA's solar orbiter making its closest ever approach to Venus, an intriguing cosmic explosion discovered in archived data, and groundbreaking findings from NASA's DART mission that changed both the orbit and shape of an asteroid. We'll also explore compelling new evidence suggesting Jupiter's moon Callisto harbors a subsurface ocean, examine the latest research on how space travel affects human health, and discuss the brewing controversy over Elon Musk's call to deorbit the International Space Station ahead of schedule. These stories showcase just how dynamic and ever-changing our understanding of space continues to be, and I can't wait to share all the details with you. So let's dive right into today's top space and astronomy headlines. The European Space Agency is making history today as their solar orbiter spacecraft performs its closest ever flyby of Venus, swooping just 379 kilometers above the planet's surface. To put that into perspective, that's even closer than the International Space Station orbits above Earth. This incredibly precise maneuver serves a fascinating dual purpose. While Venus itself isn't the primary target, the planet's gravity will act like a cosmic slingshot, gradually altering solar orbiter's trajectory to achieve something remarkable, a unique vantage point of the sun's elusive polar regions. The mission team at ESA's European Space Operations Center has meticulously calculated every aspect of this gravity assist, which will occur at precisely 21:48 Central European Time. The flyby presents some interesting technical challenges, particularly when it comes to thermal management. As the spacecraft passes Venus, it will be bathed in intense infrared radiation from the planet, causing a significant temperature spike. While solar orbiter's cameras won't be able to capture images of Venus during the encounter, since the spacecraft needs to maintain its sun-facing orientation, its suite of instruments will still be hard at work. The spacecraft's magnetometer and plasma wave sensors will gather valuable data about Venus's unique magnetic environment and its interaction with the solar wind. This flyby is actually part of a larger celestial choreography. By using Venus's gravity in this way, the mission team can gradually tilt solar orbiter's orbit out of the flat plane where planets orbit the sun. This will ultimately give us unprecedented views of the sun's poles, regions that are crucial for understanding solar activity and space weather, but have never been directly observed before. The insights gained from these future polar observations will be invaluable for predicting solar storms that can impact our technology on Earth, from power grids to satellites and communication systems. This makes today's precise dance with Venus an essential step toward better understanding our star and protecting our increasingly technology-dependent civilization. Next up on today's agenda, in what astronomers are calling a remarkable needle-in-the-haystack discovery, researchers have uncovered evidence of a powerful cosmic explosion that had been hiding in plain sight for years. This mysterious burst of energy, now designated XRT 200515, was found buried within 2 decades of archived observations from NASA's Chandra X-ray Observatory. Using innovative machine learning techniques, scientists at Stanford University and Harvard spotted this extremely bright and fast X-ray flash that appeared and vanished within mere seconds on May 15, 2020. What makes this discovery particularly intriguing is that it occurred in the Large Magellanic Cloud, one of our nearest galactic neighbors. The burst exhibited some unusual characteristics that set it apart from previously observed events. It produced an incredibly energetic initial burst lasting only about 10 seconds, followed by a longer but less intense afterglow that continued for several minutes. What's even more mysterious is that neither Chandra nor any other telescope has ever recorded activity from this source before or since this explosive event. Scientists are considering several fascinating possibilities to explain this cosmic flash. One leading theory suggests it could be the first X-ray burster ever discovered in the Large Magellanic Cloud. These rare systems consist of 2 stars locked in a cosmic dance. A super-dense neutron star pulling material off a companion star until it triggers a massive thermonuclear explosion. Another possibility is that we might have witnessed a rare giant flare from a magnetar, a type of neutron star with an incredibly powerful magnetic field. If this turns out to be the case, it would mark the first time such an event has been observed at these specific X-ray energy levels. The discovery also highlights the value of using artificial intelligence to comb through astronomical archives. As lead researcher Stephen Dillman noted, there might be countless other discoveries waiting to be found in observations we've already made. The research team is now fine-tuning their methods to search for even more hidden cosmic phenomena, including potential signs of planets beyond our Milky Way. One topic that seems to be getting a lot of coverage in the media at the moment: just how do we deal with any asteroids that might be about to collide with us? Well, maybe there are some answers in this new report. NASA's DART mission continues to reveal fascinating new details about its impact on the asteroid Dimorphos. A recent JPL-led study has shown that the spacecraft's collision with the 560-foot wide space rock did far more than just nudge it off course. It fundamentally altered both its shape and orbital characteristics. Before DART's impact, Dimorphos was roughly symmetrical, resembling a squashed ball that was wider than it was tall. It maintained a well-defined circular orbit around its larger companion asteroid Didymos, taking just under 12 hours to complete each loop at a distance of about 3,900 feet. But the collision changed everything. The impact transformed Dimorphos from its relatively symmetrical form into what scientists call a triaxial ellipsoid. Picture something more like an oblong watermelon. More significantly, its orbital period has been reduced by 33 minutes and 15 seconds, with remarkable precision measured down to just 1.5 seconds. The asteroid's orbit has also become slightly elongated rather than perfectly circular, and researchers have observed that Dimorphos now rocks back and forth as it travels around Didymos. The impact pushed it about 120 feet closer to its companion, with its average orbital distance now measuring around 3,780 feet. These findings come from an incredibly precise analysis combining 3 key data sources: DART's final images before impact, radar observations from the Deep Space Network's Goldstone facility, and extensive measurements from ground-based telescopes worldwide that track changes in the asteroid's brightness over time. The results align with other recent studies suggesting that Dimorphos is what scientists call a rubble pile object, similar to asteroid Bennu, rather than a solid rock. The European Space Agency's upcoming Hera mission, set to launch in October 2024, will conduct a detailed survey of the asteroid pair to confirm exactly how DART reshaped Dimorphos and further advance our understanding of planetary defense techniques. Next, exciting new research has strengthened the case for a hidden ocean beneath the surface of Jupiter's moon, Callisto. Scientists analyzing magnetic field data from NASA's Galileo spacecraft have found compelling evidence that this often overlooked moon may be harboring a substantial body of liquid water beneath its icy exterior. Unlike its more famous sibling Europa, Callisto presents a dark, heavily cratered surface that might not immediately suggest the presence of an ocean. However, the key evidence lies not in what we can see, but in the moon's magnetic properties. Callisto generates an induced magnetic field through its interaction with Jupiter's powerful magnetosphere, and this field holds clues about what lies beneath the surface. The latest analysis, published in AGU Advances, used sophisticated modeling techniques to examine data from multiple Galileo flybys. The researchers created detailed 4-layer models of Callisto's structure, considering various possibilities for the thickness of its ice shell, ocean depth, and electrical conductivity. Their findings suggest that Callisto's magnetic signature can't be explained by its ionosphere alone. It requires the presence of a conductive ocean tens of kilometers thick. This ocean appears to be buried beneath a substantial ice shell, which explains Callisto's heavily cratered appearance. The combination of a thick ice layer and a deep ocean fits perfectly with both the magnetic data and what we observe on the moon's surface. While these findings are exciting, we'll soon have even more detailed data to work with. Both NASA's Europa Clipper and the European Space Agency's JUICE mission are headed to the Jovian system, with plans to conduct multiple close flybys of Callisto. The Europa Clipper will make 9 passes, some as close as 250 kilometers to the surface, while JUICE will perform 21 flybys. These missions, arriving in the early 2030s, will carry advanced instruments that should help us definitively determine whether Callisto truly belongs in the growing family of ocean worlds in our solar system. As we venture further into space, understanding how the cosmic environment affects human health becomes increasingly crucial. Recent studies have shed new light on the various challenges astronauts face during extended periods in space, and the findings are both fascinating and concerning. One of the primary threats comes from space radiation. Unlike here on Earth, where our atmosphere and magnetic field shield us from cosmic radiation, astronauts are exposed to high-energy particles that can damage DNA, increase cancer risk, and affect cardiovascular health. This becomes particularly concerning for missions beyond low Earth orbit, where natural protection is minimal. The absence of gravity presents another significant challenge. When astronauts spend time in microgravity, their bodies undergo dramatic changes. Bodily fluids shift upward, causing facial swelling and increased pressure in the skull that can affect vision. Without the constant pull of gravity, bones lose density and muscles begin to atrophy, even with regular exercise. The cardiovascular system also experiences major adaptations. The heart doesn't have to work as hard to pump blood against gravity, leading to changes in blood pressure regulation. When astronauts return to Earth, many experience difficulties with balance and coordination as their bodies readjust to normal gravity. The psychological impact of space travel can't be overlooked either. Living in confined spaces with limited social interaction and no natural day-night cycles can lead to sleep disturbances, mood changes, and cognitive challenges. These effects become more pronounced during longer missions, raising important considerations for future deep space exploration. Perhaps most intriguing are the recent discoveries about how space travel affects human cells at the molecular level. Scientists have observed changes in the function of mitochondria, our cells' power plants, and alterations in gene expression that can persist even after returning to Earth. Some astronauts experience lasting vision problems due to what's now known as spaceflight-associated neuroocular syndrome, or SANS. As we plan for longer missions to destinations like Mars, understanding and mitigating these health risks becomes paramount. Researchers are actively developing countermeasures, from radiation shielding technologies to new exercise protocols and psychological support strategies. The human body may not have evolved for space travel, but human ingenuity continues to find ways to adapt to the final frontier. Finally today, a story straight out of the news headlines. A new controversy is brewing in the space community after SpaceX CEO Elon Musk called for the International Space Station to be deorbited as soon as possible, suggesting a timeline just 2 years from now. This proposal stands in stark contrast to NASA's carefully planned decommissioning schedule set for 2030. Musk argues that the ISS has served its purpose and offers very little incremental utility, advocating instead for a stronger focus on Mars exploration. However, this oversimplifies the station's ongoing importance as a unique research platform and testing ground for long-duration spaceflight. The ISS, which has been continuously occupied since November 2000, remains a crucial facility for conducting scientific research and developing technologies essential for future deep space missions. While the station has indeed shown signs of aging, NASA and its international partners have determined that it can safely operate through the end of this decade. SpaceX itself is actually involved in the station's eventual retirement, having been selected by NASA to build the deorbit vehicle that will safely guide the massive structure through Earth's atmosphere. This controlled deorbit is a complex operation that requires careful planning and coordination among all international partners. It's worth noting that most ISS partners have agreed to the 2030 timeline, though Russia has indicated it may wish to end its participation by 2028. Given the station's size and complexity, rushing its decommissioning could pose unnecessary risks and potentially disrupt the transition to commercial space stations currently under development. The debate highlights a broader discussion about the future of human spaceflight and whether we should maintain a presence in low Earth orbit while simultaneously pursuing deeper space exploration. For now, NASA maintains that the ISS continues to serve as an invaluable platform for research and international cooperation, essential stepping stones for our journey to both the Moon and Mars. And that brings us to the end of today's episode of Astronomy Daily. Thank you for joining me for this fascinating journey through the latest developments in space and astronomy. From groundbreaking discoveries to ongoing debates about the future of space exploration, there's never a dull moment in our cosmic neighborhood. If you'd like to stay up to date with all the latest space and astronomy news, head over to astronomydaily.io, where you can sign up for our free daily newsletter and access our constantly updating newsfeed. While you're there, you can also catch up on all our previous episodes. Don't forget to follow us on social media. You can find us as Astro Daily Pod on Facebook, X, YouTube Music, and TikTok. This is Anna, reminding you to keep looking up and wondering about our amazing universe. I'll see you tomorrow with more fascinating stories from space.